Hey, how you doing? Hey, good to see you again. Listen, I just wanted to go through that story. You were telling me about how you went over to your sister Clea's house and had dinner, nice beautiful dinner. Afterwards, you go out on her deck, you're looking over the mountains. She's giving you a glass of wine and she's telling you that the next day she's going to go into the office and she's going to demand a raise. And you said, really, why is that? And she tells you that, well, she does a better job on, her sales manager job. And you said, well, back up. Tell me who you're talking about. She said, well, listen, you always tell me to get data, get the information, get data, and I have the data. And you said, well, what's the data? What are you talking about? Well, they started a new sales class. They at the company, they hired 10 new people to do sales. And you, her, your sister, and Anthony, your two sales managers. And they divided the class into 5 people each. And they've been at it, training them out on the force, and now they've been both at it for 6 weeks. And your sister says, my team has been doing much better. I'm a better sales manager. They got to pay me. And you said, okay, well, that's good if you got the data. Let's see the data. So she hands you the data, and it's right up here on the screen over here. So as you can see, Anthony has 5 employees down the left-hand side, and your sister Clea has 5 employees down the right-hand side. And the increase, or Clea has more, by 9,322. This is weekly average for these employees, which is an increase of 11.7%. And she says, so I think that proves that I have the data. They should give me the raise. And you said, well, not so fast, actually. Yes, they have a higher average, but that could just be due to chance. And really what you have to do is you have to conduct a statistical test to determine whether that 11% increase is due to chance or if it's statistically sound. So she's getting a little worried, a little wary. What kind of test are you talking about? So, you tell her that's a T-test for independent samples. Well, you're telling me this, and I'm going, wait a minute. All right, back up. What is a T-test for independent samples? So you told me, and, put it up on the board here, that an independent T-test is an inferential statistical test that determines whether there is a statistical significant difference between the means in 2 unrelated groups. And there's a little graph here. You have 2 unrelated groups, group A, group B. What's the mean of those 2 groups? And is there a difference, a statistical significance between the means of those 2 groups? Okay, I think I understand that. That's making sense. Is there a formula for this thing? And she said, sure. And so she puts this up on the board. And I said, oh boy, one of those complicated formulas, huh? I really don't want to. Okay, well, give me a minute. Oh, I can do this. Give me a second. All right. So just give me a sec. Okay, so you're reading here that the T-test, is equal to x bar 1 minus x bar 2, and in the denominator is the square root of the standard deviation squared of the first group divided by the n, the number of people there, plus the standard deviation squared of the second group divided by n, the number of people in that second group. You add them together and you take the square root. That's the denominator, and that's your t. Oh boy, that sounds complicated. I said, isn't there another way to do it? And you said, of course, well, yeah, you do it in Excel. And I said, well, doing that in Excel sounds like a much better way. How do you do it in Excel? And so she's gave me a little instruction sheet here. It's right here. What you do is you go to the data tab, and then under data, you select data analysis. And then you select T-test for 2 samples, assuming unequal variances. You hit OK. You select the 2 ranges. And then where it says hypothesized mean differences, put a 0 in the box because your hypothesis is they're equal. You check the labels box if needed. That is, if you included the labels in the range, you click that box. In the alpha box, it's going to default to 0.05, 5%. I would recommend you leave it at 0.05. In the output, you just select the cell where you want the output to go. You hit OK, and that's how you do it. And so I said, okay, I think I understand that, but could you walk me through with a real example and the data? So you said sure. So you queued up the Excel, and this is what you did. Hi there. Okay, so now we're going to do it on Excel. So here's our data that we looked at previously. Anthony here has 5 people, 5 sales individuals. Clea has 5 individuals, and we have a total, and we strike a total, and then we strike a difference of the total, and the increase is $9,322 average sales per week, which is an increase of 11.7%. So we're going to conduct that t-test of independent samples, and Excel is going to do all the heavy lifting. We go to data, and we go to data analysis, and we're going to scroll down here to get the t-test. And the t-test we're looking for is the 2 sample assuming unequal variances. Click on that, and then we populate the ranges here. So I populated the range including the labels here for variable 1, and I calculated Anthony, and then I did Clea. You put in your hypothesized mean value, you populate that with 0. You'd click the labels if you have the labels like I do on row 6. And the alpha defaults to 0.05, which I think is a fine place to put it. And so I would leave it at 0.05, 5%. Put your output range wherever you want. I'm selecting putting in F5. And then you click OK. And there's our data. Isn't that nice? So what do we do with all that data? Okay, let's take a little better look at it. Okay. So what it's telling us here is that this is a two-tailed test. And this P, the probability here that the large T is less than or equal to the small t of a two-tailed test is 0.53. Well, since that is larger than 5%, then we cannot reject the null hypothesis. And we must conclude that the averages are similar, that the 2 sales managers, are basically substantially similar. And that's what we have right there with our t-test. It's not what we wanted, but that's what the result came out with. Okay. Oh, okay. Yeah, okay. That makes more sense. Seeing it really makes it much better. I think I see there. So at the end there, you told me that the data was not statistically significant. Could you show me that part again? So yeah, see what they're showing here is that the P, the probability of the large T being less than or equal to T in a two-tailed test, this is a two-tailed test, is equal to 0.539. And since this is not less than 5%, you cannot reject the null hypothesis. You can't make your case. It looks like they're statistically the same. Well, Clea was not real happy to hear about this. And she says, wait a minute, I got 11% higher. How can that not be statistically sound? And you say, well, that's just the way it is. You need to have, a better set of data. And she said, all right. So she thought about it and she said, all right. You know what? My team is definitely better. My team's better. 6 more weeks are going to go back. We're going to do even better. I bet we'll do double. We'll do triple. That'll be better, right? And so you said, well, maybe, but maybe not. How about we test that? So what you did is show up here. We put in the same. Anthony did the same as before, but your team, Clea, really banged it out in the next 6 weeks. And according to this data, your increase is 28,662, and it's a 36% increase. Well, certainly, wouldn't that be much better, your sister says? Well, let's conduct the test. So you went through the same scenario before. You click, 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 and you come through. And the probability of the T is less or equal to the small t on a two-tailed test is equal to 0.1613, which again is not less than 0.05. You cannot reject the null hypothesis. Well, Clea is not real happy about this. She's, I understand. We're giving you all this data. I'm doing the gangbusters. How can this not be statistically significant? So you're explaining to her is the point is here, we're trying to rule out chance. We're trying to rule out chance. And the best way to rule out chance is to enter more data subjects, more people in the pool. At N of 5, is very small. If we can get an n of, say, 12, perhaps we could try again. Okay, well, let's, if we could get a pool of 12 each, 12 on each side, what would that look like? So we ran another scenario. Now, this isn't actual data. We're just trying to understand where it would come in. And we still have, under this scenario, 12 people. We still have an percentage increase of 36%, like last time. Okay, well, let's run through the t-test. And you can see here that the probability of the large T less than or equal to the small t for a two-tailed test is now 0.004. That's less than 1%. So now this is less than 0.05, and so you do reject the null hypothesis. So Clea takes another sip of wine and she says, so I guess what you're telling me is that I can't really go into the office tomorrow and demand a raise. And you said, well, you certainly don't have the statistical test, to prove it. You can't prove that you're better, at least not with this data. So she said, all right, you know what? I guess it's a good thing we talked. Sometimes I go off half-cocked, and it's a good thing that you wised me up to this. And so she said, what should I do now? And you told her, cut yourself some more turkey, because you want to have a lunch tomorrow with a turkey sandwich. And anyway, that is why you are one ace accountant. Let's give you a big round of applause. All right. See you later. Bye-bye.